Okay, so I'm going to do two double integrals over general regions. So the key strategy to do this is to, first of all, find out what your region is, and then decide whether to integrate with respect to x or y first, and then get your bounds from that. Okay. So for this one, we have to double integral over the region D of x squared plus 2y dA, where D is the region bounded by y equals x and y equals x to the fourth. Okay, so first of all, let's draw the region out. Okay, so y equals x looks like a straight line, and y equals x to the fourth is like a parabola. Something like that. Okay, and this is your region D. Okay, it's probably helpful to get these points of intersection. So this is over here 0, 0. And then over here would be 1, 1. You could solve the system's equations, or you could just simply do a little plug in and check. Okay. Now, how do we determine whether to integrate with respect to x first or y first? Well, for this one, it doesn't matter too much, but because of how the problem is given, as y equals x and y equals x to the fourth, so y as a function of x, it's probably easier to integrate with respect to y first, okay? So how do we get our bounds? So let me write this out first. So y first, and then x. So how do we get our bounds for y and x? Well, let's see what our y is. So minimum y, or not minimum, but the lowest y is this curve right here, and our highest possible y would be everything bounded by the straight line right here. So we will integrate from x to the fourth to x. Again, once again, because this is the lower bound for y, the x to the fourth function, and then y equals x to the upper bound for y. Okay, so now that we took care of y, we can take care of x. So x is just simply from 0 to 1, because we got the shape of the region by y already, so we could just get the simple numbers for x. Okay. So let's do the y integral first. X squared plus 2y dy. So what is this equal to? Well, this has no y, so it'll be x squared y plus y squared. So that's just the parabola, and then this is from y equals x to the fourth to y equals to x. Okay. So if you do the fundamental theorem of calculus, plug in y as x and y equals x to the fourth, you would end up with x to the third plus x squared minus x to the sixth minus x to the eighth. Okay. So I'm not going to do all that algebra over here. So now we can integrate with respect to x. So we have 0 to 1 over here, and then this thing right here. And as you can see, this is simply just the parabola. Oops, x to the 6 dx. Okay, so this is simply the parabola. So we have 1/4 x to the fourth plus 1/3 x cubed minus 1/7 x to 6 minus 1/9 x to the ninth, evaluated from 0 to 1. So this is simply just 1/4 plus 1/3 minus 1/7 minus 1/9. And you could leave your answer at this list. Okay. Okay, now let me do the other one. So this one is double integral over the region D of y plus 2x dA, where D is the region bounded by x equals 2y squared and x equals 1 plus y squared. So you might freak out because like you might think like, what is this? Y squared equals something? Well, this is simply just a parabola still, but instead of going up and down or up or down, it's opened up to the side. Okay. So again, let's draw the region out. Probably need this longer. Okay. So x equals 2y squared is just simply a parabola that's stretched by 2, so it looks something like this. Very rough sketch. Okay. And then x equals 1 plus y squared is just simply not a parabola, but it's shifted over by 1. So that's where the vertex would be, and then it looks something like this. Okay. Something like that. So here's your region D. Okay. It's probably helpful to get the points of intersection again. Okay. So this one is not as easy to tell, so and guess and check, so let's solve the systems of equation. So this is x equals to 2y squared and x equals 1 plus y squared, so let's set them equal to each other. Okay, so this becomes y squared equals to 1. Okay, and then this is y equals plus or minus 1. Okay. And then x would simply just be 2 if we plug that in. So this over here is 2, 1, here's 2, negative 1. Okay. So again, which one should we integrate with respect to first? Y or x? So for this one, the big hint is just how the problem's set up. You give functions x equals something, so you probably want to integrate with respect to x first. Also for this one, you could easily tell that it's x because if you integrate with respect to y first, so you can't really get a simple function as your upper and lower bound for y, as you can see, because this is the upper bound, but this also bounds it. This is the lower bound, but this also bounds it. So we should integrate with respect to x first. So you can easily tell your upper and lower. So this would be your upper, this would be your lower. Okay? So again, let us just do y plus 2. So I said x first, so dx dy. And again, how do we get our x bounds? So this would be your rightmost, or you can think of it as uppermost if you want to flip your graph over. This would be your uppermost x bound, this function over here, which is the 1 plus y squared function, and the lower one, the 2y squared function, is your lowest x bound. So we plug in as 2y squared and 1 plus y squared. Okay. Now for for y, we could simply just get the y bounds, which is from negative 1 to 1. Okay. Okay. So let's take care of the y integral, the x integral first. This pen's like dying on me. Dx. Okay. It's simply just x, y plus x squared, y from x equals to 2y squared equals to 1 plus y squared. Okay. And then when you do the fundamental theorem calculus, plug in x as 1 plus y squared and x as 2y squared. I'm not going to do all the algebra and stuff here, but you would get y minus y cubed plus 1 plus 2y squared minus 3y to the 4th. Okay. Now let us take care of the y integral now. So this is from minus 1 to 1 of y minus y third plus, whoops, this pen's not working, plus 1 plus 2y squared minus 3y to the 4th dy, and this is simply parallel again, half y squared minus 1/4 y fourth plus y plus 2/3 y cubed minus 3/4 y, 3/5, sorry, y to the 5th, let me rewrite that, minus 3/5 y to the 5th. This is evaluated from minus 1 to 1. Okay, and notice you can't do any shortcuts with this because this is not an odd function or even function. Okay, but anyway, if we plug it in, so I'll work this out. So this is half minus 1/4 plus 1 plus 2/3 minus 3/5, and then minus, plug in negative 1, so half minus 1/4 minus 1 minus 2/3 plus 3/5. Okay, and you'll see that some terms cancel out. So for example, this half and this half and then minus 1 for that 1 plus, so this cancels, and then these do not cancel. So it'll be 2 plus 4/3, and that'll be minus 6/5. So that's your answer. Okay. So once again, what's the general approach for these double integrals over general region problems? First of all, you want to probably sketch your region out, probably helps, and then you want to determine whether to integrate with respect to x or y first, and then you determine your bounds for x and y. Okay, so for example, for this one, with respect to x first, because it's easy to get your x bounds in terms of y, and then for this one, it didn't really matter too much for this one.